How are you guys? Good morning. How's everybody doing? Should we wait a minute or should we just get started? You guys excited to finish? Okay, so the last thing I covered was chapter 12, right? So all we have left to do is I forget if I put up the quizzes for 12. I can't remember, so I'll check your Canvas in a minute. But what I wanted to do is do exam 3 review, and then kind of just like post exam 3, and then have you guys do that within the span of a couple of days. And then on Thursday we do our final exam review. We do part 1, hopefully part 2, and then the next Tuesday, if we are not finished, we'll finish it, and then we'll take our final. So ideally, we'd like to get to where we finish the final all in one setting, like we just do the whole review on Thursday, and then Tuesday we take our final where it's proctored, and we all do it together via Zoom. So that's the only other thing. I think the assignment has a setting where it's called like a respondus or something, where it locks your browser so you're not able to go on to other things. And I'm not sure, I think that may be activated for our final. So just heads up, make sure that we are all on the same page. I'm sorry. It's hard to get up now. Okay, all right, cool. Yay, so I'm excited. So I'm very excited for us. I think we, as a class, have been doing really well, and it's just good considering the very crazy circumstances. Really, I'm really glad that you guys stuck it out, so it's good. Okay, so let's see here. Question 1. You guys ready? You guys have this in front of you? I sent this to you, right? I'm pretty sure I sent it to you, but in case I didn't, just in case I did not, this is what it is. Okay, so that's what I'm going over. Okay, so that's a key anyway. So it says here, as SEO account manager is concerned, website developers are using too many keywords. They would like to carry out a hypothesis test and test the claim that the web page has on average more than 10. Why is this test right-tailed? So they want to test that the web page is more than 10, right? So basically the direction is specified. The parameter is greater than the specified value, right? So right, so the parameter, which is, it's greater than, so it's right-tailed. Any questions on this one?
No.
Okay, cool. All right, let's continue. So then a dental assistant is interested in the proportion of patients that need a root canal. Let the proportion of patients that need a root canal be lowercase p. If the dental assistant wants to know if the proportion of patients that need a root canal is more than 20%, what are the null and alternative hypotheses? So remember that it has to be, they want to know if the patient's is more than 20%, right? And remember the null is either equal sign or less than or equal to, greater than equal to, but it always has an equality, and that the alternative will never have an equality. So we know that the alternative has to be either this one or this one, right? But then again, they're asking for P, so it's not the mu. So it has to be C. Oops. Yeah. Just thinking that I want to go over this again with my other class, and then they're just going to see the answers. Okay, so question 3. Identify type 2 error if the null hypothesis is Anna believes the capacity of her gas tank is 10 gallons. And that's it. So select the correct answer below. So what would the type 2 error be? So remember, type 2 is to we reject the truth, right? There is insufficient. So basically, we're basically saying we fail to reject the null when in fact it's false. Type 1 is reject the truth. So basically, type 2 error would be there is insufficient evidence to conclude that the capacity of the car's tank is not 10 gallons, in fact, when it isn't 10 gallons. So basically, type 2, we fail to reject an incorrect null hypothesis. Okay, so yep. Any questions on this one?
No.
No, pretty straightforward. Okay, let's continue. Here, question 4. What is the p-value of a right-tailed one mean hypothesis test with a test statistic of z0 equals 1.07? So there's 2 ways to do this. We can do the table, right? Or we can do what's it called? The normal CDF on our calculator, because it's right-tailed. So you don't have to use the table. Basically, they're asking what is the p-value of z, it's right-tailed, so it's greater than 1.07. Okay, that's what they're asking. See that? Okay, so we can just do, let's see here. So we can do second distribution, normal CDF, since it's greater than, it's 1.072, comma, and then 9999, and then since it's already z-score, we could just hit enter, and then your answer is 0.142. So we can do normal CDF 07,9999, and then that'll give you PZ greater than 1.07. But let's just say for funsies, you wanted to use the table. What if you wanted to use the table? Well, Z of 1.07. So remember the table. The table gives us all the values for P, Z less than some number. Okay, so it's always going to give us the left side. So since this is P of Z less than 1.07 will be 0.858. P of Z greater than 1.07, or this could be equal to, it doesn't matter. Remember, it's just the area. Would be 1 minus P of Z less than. It's the complement, right? So this would be 1 minus 0.858, which would give us the same thing of 0.142. Okay, so that's using the table, but it's easier on that calculator, right? Okay, so just stop me if, I'm just gonna keep going, and if you have any questions, please feel free to stop me. Okay, so question 5. The following data was calculated during a study on weight loss, and then it says interpret the p-value for this hypothesis test. Just take that. Okay, a doctor would like to test the claim that the average weight loss after participating in a diet program is less than 10 pounds. The test statistic is z naught equals negative 2.5, and the p-value is 0.0062. Okay, so we're interpreting the p-value. So let's see here. So it's asking if it's less than, okay, and then what else do we know? Z is this, and we know the value is 0.062. So basically, here's the probability of getting Z negative 0.25 or less is equal to 0.0062. So that means the probability of getting this value is 0.62%, of getting less than Z score of less than 2.5. Okay, so that would give you that would be this. So, any questions on this one?
Not yet.
Not yet. Okay, cool. Okie dokie. All right, so here, number 6. Sorry, 6. Let me just center in here. Okay. A local marketing firm was wondering if, if average mall goers spent more than $25 at the food court each trip. The firm surveyed its shoppers and received 10 responses. Using the results from the current survey and several previous surveys, the firm has decided to assume that the population standard deviation for the amount spent on the at the food court was $11.2. Okay, so then they conduct a one mean hypothesis at the 5% significant level to test if the average amount spent at the food court is greater than $25. So that's the test. And then it says here the amount that the shopper spent at the food court is given below. We need to use TI-84, TI-83, TI-83 plus, or 84 calculator, right? So what are they giving us? They're giving us the population standard deviation is 11.2. Okay, and then they're giving us, so funny. The firm surveyed the shoppers and received 10 responses, so 10 people were asked, right? And we're trying to find greater than. So we're doing a Z-test, right? So first we need to enter the data. So let's go ahead and enter the data into our L1. So we would do stat. Sorry, let me just. Give me 1 second. Hold on. Can you stop scratching, please? I'm trying to teach a class. Sorry, my dog is annoying. Okay, so we first enter everything into L1. So let's see here. We have here. Stat, edit. Make sure we clear our data. Okay. So, 3. $16. Oops. Okay. So now that we have everything in our L1, we're going to do stat test and Z-test. Okay, so stat test, Z-test. So let's see here. So stat test, Z-test. So into L1, then you hit stat test, and then Z-test. Oh, sorry. So then you have your hypothesized mean. So that's like they want to know if it's greater than 25, right? So that would be 25 here. And then your standard deviation, your population standard deviation is 11.2. Your list is L1, frequency 1. And our alternative hypothesis is that it's greater than, so we select that. Okay, and then we hit calculate. Mom, it's usually louder. Can you guys get the dog, please? Okay, so that's it. So now we have all our stuff. We have what does it say here? It wants the test statistic and the p-value. So oh gosh. So the test statistic will be 0.93. And the p-value is 0.1757, or approximately 0.18, because it says 2 decimal places. So not too bad. Okay. According to a survey, the average American watches TV for 3 hours per week. To test that the amount of TV in New York City is less than the national average, a researcher tries to do a hypothesis test at a 1% significance level. She surveys 19 New Yorkers randomly and asks them about their amount of TV per week on average. From the data, sample mean time is 2.5 hours per week, and the standard deviation is 0.9 hours. Okay, so we need to know the t-value of this one mean hypothesis test, because we do not know the standard deviation. We just know the sample standard deviation. Okay, so we can do a couple things. TCDF, I guess, or we could do inverse T, but not everybody has inverse T. So since not everybody has inverse T, we could use the following equation. So the following equation to find a T test statistic, it's similar to the Z-score in this case. So X bar, remember from the mean, all over, instead of standard deviation, it's S over square root of N. So here we have all our things. So we have the sample mean time is 2.5. The sample standard deviation is 0.9. What else do we have? N is 19. And the hypothesis, like mean, is 3. So you could say mu sub 0 is 3. Okay, so that's everything. So we just plug it in. So the t-score will be 2.5 minus 3 all over 0.9 over square root of 19. Okay, and then when you plug that in to your calculator, you'll get that t is approximately, we need to do 2 decimal places, so it will be negative 2.42. Okay. Any questions on this one? Okay. All right, let's continue. Question 8. Question 8. Okay, we have here the shift supervisor of a pizza parlor. Oh, sorry. Pizza doesn't, coffee does nothing. The shift supervisor of a pizza parlor claimed that the population mean total time to deliver pizza is exactly 45 minutes. Paige, the owner, this is so much info, would like to find evidence that the population mean time, total time to deliver pizza is less than 45 minutes. So she records the total delivery time of 71 randomly selected deliveries, and she finds the sample mean with the sample standard deviation, right? So what else does she finds the t-test here. And she says, let's see here, is t is approximately negative 2.29. So then the p-value is between 0.01 and 0.025, and the level of significance is alpha 0.05, so 5%. Which of the following statements are accurate for this hypothesis test to evaluate the claim that the true population mean total time is less than 45 minutes? Okay, so basically, remember the p, this is all we need, right? So all this, we have here that alpha is 0.05. So remember, when p-value is less than alpha, we reject the null, and we support the alternative, okay? So the null hypothesis is that it's equal to 45, right? So we're rejecting the null hypothesis that the true population mean time is equal to 45 minutes. So that would just be A. That's pretty much it. All of this is just asking, do you know what to do if your p-value is less than alpha? That's about it. Okay, so, all right. Then question 9. We have here the following data was, let's see, following data, was calculated during a study on credit card debt. Using the following data, how would we interpret the results if the significance level was 1%? So we have greater than 3.9 thousand, t is 0.148, and the p-value is between 0.05 and 0.1. So it's really important. So our alpha is 0.01, and our p-value here is, it's somewhere in between 0.05 and 0.1, right? So it's going to be, p-value is between 0.05 and 0.1. This, however, is still greater than 0.01, either one. Wait, yeah. 0.05 is greater than 0.01, right? So, and 0.1 is definitely greater. So in this case, p-value is greater than alpha. So it's the opposite, right? So in this one, we fail to reject the null. So, so we fail to reject the null because why? So when you fail to reject the null, that is you also cannot support the alternative hypothesis. Okay, so because we can only do that if we reject the null. So it says here there is not strong evidence to conclude that the average amount of credit card debt for a small business is greater than. Yeah, so we can't support any other argument. We can't support the alternative hypothesis because we did not reject the null. So it would be A. Okay. All right. You guys doing okay there?
Yes.
Yeah? Okay. All right, so question 10. A stats professor gave an exam on performing t-tests with sigma unknown. Exam had bonus question, guess the average score if a t-test was performed and the mean guess for the class is not significantly different than the true average. Everyone in the class will receive 2 bonus points, and there were 10 students that took the final exam. The true average exam score was 89.3. All right, so let's see here. Professor conducts a one mean hypothesis test at the 5% significance level to test if the mean guess for the class is not significantly different from the true exam score of 89.3. So what would be a correct null and alternative hypothesis? Because it's different, right? So you can have either that, remember the null has to be the true test mean, and the alternative is that it's different. So that would be here, two-tailed test. So HO is always equal, and then HA would be that, I'm sorry, this would be that mu is equal, and then this would be that mu does not equal, okay? Okay, all right. So question 11, you have here, Bruce, the store owner, would like to determine if a new advertising initiative has increased the proportion of sales he makes to women is more than 75%. To test this, he gathers information on a 150 random sales and finds that 120 of those sales were made to women. So this is the setup for the hypothesis test. We have equals to 0.75%, and then the alternative would be greater than. Why? Because he wants to know if the sales have increased, the proportion of sales have increased. Okay, so if we have a p-value, so we did all the thing, and then we have a p-value of 0.07. So if alpha is 0.01, what do we conclude? Okay, so we have here that p-value is 0.079, alpha is 0.01. So in this case, p-value is greater than alpha, so we fail to reject the null and fail to support the alternative hypothesis. And it does not support alternative. So you would say there is not sufficient evidence to conclude that the proportion of sale he makes to women is more than 75%. Why would you think it was 50%? That's weird. Okay, so that would be B. Okay, cool. Any questions on this?
No.
Sorry, guys, my kids are goofing off back there. Give me a second, sorry. Sorry about that. It's a lot of exuberance going on. Okay, so question 11. So we're on question 12. All right. Question 12. Let's see, can you guys see that? Let me just relate this a little bit. Just zoom in here. Okay, great. So we have here an accountant associate is studying various tax deductions available for corporations. They would like to test the claim that the percent of corporations that can deduct employee benefits is less than 49%. They decide to complete a hypothesis test at a 5% significance level. They sample 60 corporations and determine that the sample percent to be 40%. So the following is the data from this study. So sample size is 60 corporations and sample proportion is 40, right? So we need to identify the null, okay? We have, they would like to test the claim that the percent is less than 49. So that already should tell you your alternative hypothesis, okay? Because they're trying to test that it's less than. And remember that the equality goes with the null. So the null would be that it's equal. Okay, so then basically here you just have to put in an equal sign and then the less than. It's a pretty simple question. Maybe this test is too easy. Is this test too easy?
No.
Okay, good.
I think it's good enough. Like,
It's okay. It's challenging enough.
challenging enough as it is.
Okay, so question 13. A business manager who works at a manufacturing plant is interested in determining determining whether part-time employees at the plant earn a lower rate than full-time. So we test this claim by collecting data at the hourly rates of a random sample of 31 part-time employees and 33 full-time. The average hourly rate for the part-time is $25.72 with a standard deviation of 2.4, and the hourly rate for the full-time employees is 27.62 with a known standard deviation of 3.3. So it says here at alpha is equal to 2.05, is there sufficient evidence that part-time employees have a lower hourly rate on average than full-time employees at the manufacturing plant? So we have two samples. Okay, so we have a test statistic of z equals negative 2.65. Determine the p-value from the table. Do not round your answer. So, so this is a situation where you have two samples, and our alternative hypothesis is that the first sample is less than the second, right? So remember when we this is a left tail test where we find the difference, and then we we can either compute it this way, right? And we give they give us the test statistic z naught is equal to negative 2.65 negative. Sorry, that looks gross. And then we need to find the area to the left. Okay, so you can use the table. So if we have a negative 2.65, you see that the table, right? Because this is negative 2.65. So it's 2.6, and then that's a 0.5, so 2.65. So the p-value for z less than negative 2.65 is equal to 0.004. Could we have also used normal CDF? Yes, of course we could have. Okay, so let me go ahead and show you how to do that. I'm sure you guys already know, but still. Okay, so let's see. Okay, so clear. Distribution, normal CDF. Now in this case, it's to the left. So it would be negative 9999, comma, negative 2.65, okay? And that should give us the same 0.004. So p-value is 0.004, okay? You could also do normal CDF. I'll just write it there in case for those that are dying to know. Okay, all right, cool. That's it for this one. Really short question. Okay, so question 14 says, identify the null and alternative hypotheses in the following scenario. So determine if battery 1 lasts longer than battery 2. The mean lasting times of the two batteries are compared. So 20 batteries of each type are randomly sampled and tested. Both populations have normal distributions with unknown standard deviations. Okay, so it's saying to determine if battery 1 lasts longer than battery 2, so we compare the two times. So since it's battery 1 longer than battery 2, okay, so the mean time. So then the null would be either that it would be that it's either equal to or less than or equal to. Okay, so those are the two options. This is the contradictory argument, and this is the alternative hypothesis. So it would be, which one is this one? This is E. Yep, so. All right, 15. A tutoring company claims that their preparatory classes would improve students' performance on a widely used standardized test. 1 year, a checkbox was added to the test for students to indicate whether they attended prep classes. Researchers selected a random sample of 1,000 tests. The sample mean score was for the 257 students who attended classes was 592 with a sample standard deviation of 72. Sample mean score for the 743 students who did not attend preparatory classes was 571. Determine the degrees of freedom for a two-mean hypothesis test for population variances assumed unequal. So non-pooled to test whether the population mean score is greater than. So when the population variances are assumed unequal, so you say the degrees of freedom are the smaller of either n1 minus 1. Okay, hold on, let me write this first. So n1 is 257. Sorry, 257, because there's two samples. So 257, yeah. And then x bar 1 would be 592, and then sample definition 72, 1. And 2, 743 students who did not enter preparatory class was 571 with a sample standard deviation of 72. Okay, so, I mean, sorry, oh, this is 164. Okay, so when you do these, degrees of freedom is n minus 1, where n is the lesser. So which one's smaller? So this is only when what? Why didn't we do n minus 1 times n minus 2, or why didn't calculate degrees of freedom in a different way? This is because population variances were assumed unequal. So when population variances are assumed not equal. Okay, so when they're assumed not equal, you can do that. Let's see here. So this would be 257 minus 1, so that's just 256. So degrees of freedom equals 257 minus 1, which is 256. Okay? So let's just subtract 1. All right. So question 16. How many questions? We have like, why is this test so long? Just kidding. Who wrote this? Okay, so the partners in investment firm want to know which of their 2-star financial planners, Braden or Zoe, produce a higher mean of return for their clients. The mean rate of return for Braden's sample of 30 Braden's clients was 3.54% with a standard deviation of 0.92. For Zoe, it was 30 clients, 3.87. The mean rate of return was 3.87, standard deviation of 2.08. So mu1 is a population mean rate for Braden, and mu2 is rate of return for Zoe's clients. Partners assume that the population standard deviations are not equal, and since Zoe's mean is higher, test the alternative that mu1 minus mu2 is less than 0. So if the p-value is greater than 0.10 and the significance level is 0.05, what conclusion can be made about the population mean rate of return? So we have p-value is greater than 0.1, but alpha is 0.05. So in other words, p-value, but this 0.01 is definitely greater than 0.05, so p-value is greater than alpha. Okay, so what happens when p-value is greater than alpha? We fail to reject. So all of that, reject. Okay, oh, but then there's more, right? Is there more? Yeah, because it says identify all the appropriate conclusions. So we fail to reject the null as one of them, but then if we fail to reject the null, we'd say that there is insufficient evidence to suggest that the population mean rate, isn't this the same solution? Yeah, so C and D are the same, right? Oh, that's weird. So it would be B, C, and D. Right. Okay, so it's yeah. That's interesting. They just repeated the same solution. That's so weird. Okay, so question 17. Okay, 1 point. In order to check for regional bias in a widely used standardized test, researchers check for difference in the means of random samples of scores from two regions. The sample mean of the 110 scores was 497, with standard deviation 112. Sample mean for the other was 511 with standard deviation 114. U1 is, we want to know if they're different. So that means that our alternative hypotheses is going to be that mu1 is different than mu2. In other words, the difference is not equal to 0. Okay, so we have the test statistic and we have the degrees of freedom. So basically, you want to know what the p-value is for the hypothesis test. So let's see here. What's the p-value for the hypothesis? And then they give you the degrees of freedom, 208. Okay, so we know that the test statistic is negative. Okay, so let's see here. So let's see, we have 208, and then if it's negative 0.9, then the test statistic is, what's the p-value for this hypothesis test? P-value is greater than, so we could do a couple of things. We can do, this is not equal. We could just do t-test on this, or we could use this table. Why would we not want to use the table? Well, we know that negative 0.9, this is the table. This is the table of areas for in the right tail. So, so this would be less than. This is 0.10 is complementary to 0.9, so that we would use 1.286, but then it would be twice that, twice whatever 0.10 is. But let's do something else. Let's try the calculator for this one. So we would use second quit, clear this. Let's see, distribution, TCDF. So we just want to do does not equal. So we're going to do one side, and then we'll do times 2. Okay, so negative 999 up to negative 0.9, and then we're going to do degrees of freedom is 208. 208. Okay, we take this and we're going to multiply that by 2. So it's going to be pretty large. It's going to be greater than 0.10 in any case. So, it's D. Okay, so let's see what else can I say. Okay, let's see here, question 18, which got cut off. Oh, it's like 2. Question 18 is pretty crazy. It's like large. So let's go to the bottom because you need this table also. So a school district has a standardized test that it uses to sort students into magnet schools where the test is 200-point scale. And then we're given this 20 male, 20 female. And we assume the population variances are normally distributed, and male is the first sample, female is the second sample. We want to know if they have a different score, so it's a two-tailed test, right? Because mu1 is different than mu2, or not equal. Okay, so now we have all this information. So we need to put in our data into our calculator. Okay, so what we need to do is two-sample t-test. Two-sample t-test. Okay, so first thing that we do is enter everything into L1 and L2. Okay, so this is L1, this is L2. Okay, so I'm going to just quickly enter that. All right, here. Let me just be really quick about this. So L1 is. Okay, I'm still entering. I'm just trying to do this quickly. Okay, so now I have it all entered into L1 and L2. So enter into L1 and L2. Okay, so then once you do that, we need to go to, let me just zoom in here. So let's quit that. Oh, sorry, what did I do? Quit. All right, so then we do a stat test, and we want a 2-sample t-test. Okay, so we have here L1, L2, frequency same, and we have that that mu1 does not equal mu2, and then the population variances are assumed to be equal. So this one is that they are assumed to be equal, so you use a pooled, it's considered pooled. So population variance is assumed to be equal, implies pooled variance. So yes, you hit pooled. Okay, and then you hit calculate, and that's your information. So you have your t statistic is, yeah, I did something wrong here. Did I do something here too? I have a different, let's see here. Let me just really quickly check my, so let me set, edit, the two lists. 1, 2, 4, 2, 4, 2, 1, 2, 7, 1, 3. Ah, I messed up here. I entered this wrong. See, 103 and 107. 19, 122, okay. All right, so again, sorry about that. So I entered it incorrectly. So stat, test, 2-sample t-test. We have everything pulled, yeah, okay, enter, then go to calculate, boom. Okay, there it is. So our t-score is negative 0.69, and our p-value is 0.492 approximately. So I guess the only word of advice I could say is check your entry. Check L1 and L2, because it's very common. Like, I just made a mistake. I just entered it wrong because I was going quickly. So, just check that. Okay, so next question. A physician wants to test 2 blood glucose meters to see if there are any differences in measurement. So he measures the glucose in blood samples taken from several randomly selected patients with both meters. Set the difference D for each trial as computed as meter B minus meter A. Assume the measurements are normally distributed and round the test statistic to 3 decimal places. Okay, so what we do here is we need to find the differences. So differences, which is meter B minus meter A. So this gives us a list. So if we take this minus this, right? That's going to be negative 0.5. This minus this is 0.7, right? This minus this is negative 0.9. This minus is 0.8. It's 2.3. Negative 1.2. This minus is 2.6. 2.0. 2.1, and then 1.5. Okay, so that's, you have to write the differences first. Okay, and then we need to write, we can do a t-test on this. So let's do a t-test on this, okay? Let's see, second quit, clear. So that means we need to delete our previous work, which is fine. So we click that, and we just enter everything into L1, so negative 0.5. Wait, why is it? Negative 0.5, 0.7, so I'm doing negative 0.5. I'm basically entering all these into L1. Dude, oh, okay, I see what I did wrong. Okay, 0.7, and then negative 0.9, 0.8, 2.3, negative 1.2, 2.6, 2.0, 2.1. Okay, so then, second quit, SAT test, t-test. We want to know if there's any differences. So it has to be, the difference is does not equal 0. So we calculate this, and we should get, so here it is. So basically, okay, let me just, I'm sorry, I don't think I showed that here. So SAT test, t-test, then data, so it's 0. Because, why is it 0? Because you want to know if there's a difference. So that means that mu 1 is different than mu 2. In other words, that if you take the difference, it has to not equal 0. Okay, so then that means that your initial, because we're using the differences, we need to do, we need to have 0 as our mu naught. So this is a 0. So here's our L1 frequency, and then the alternative is that they're different. So there you go. And then you hit calculate. Okay, and then that's your, these are your answers. So T is approximately 3 decimal places. So 1.01, and then 6 makes this a 5. And then our degrees of freedom. So our degrees of freedom is just n minus 1. So that's just 10 minus 1, oh sorry, 10 minus 1, which is 9. So degrees of freedom is 9. And that's all they wanted. It also gives us the sample standard deviation and the p-value, but that's not what we needed for this test, for this example. So that's 20, and then 21. 21, a professor claims that his average, oh, glitching? I just read the chat. Did you guys think we need to do any over, or are we cool up to now? Okay. So you have here average scores is different than the average score in the second. He takes a random sample of students and compares their scores on the 2 exams. So here we have a random sample of 8 students where each difference is calculated by subtracting percentage score from the second, from the first. Assume that they are normally distributed. We have a t-test statistic of 0.704, and then the significance level was 1%, and the p-value was greater than 0.10. So we need to draw a conclusion. Okay, so where the alternative was does not equal and the null was equal. But the p-value here is greater than 0.1. So there's two possibilities. So p value greater than 0.1, alpha is 0.01. So definitely by these two pieces of information, we can gather that p-value is greater than alpha, so we fail to reject. We fail to reject the null. So we fail to reject the null, that means that there is insufficient evidence, right? Because that means we cannot support the alternative. Or insufficient, right? Evidence. So this one, it would be here, D. So this would be B and D. All right. Question 22 is very similar, except that they want to, let's see here, what do they want? They say it's the same, looks like the same here, the same setup, okay? So we have t-test statistic is 0.04, which has 7 degrees of freedom. What range contains the p-value? T-test statistics of 74 with 7 degrees of freedom, and then what range contains the p-value? So what you have to do is say, okay, well this is kind of, this kind of is, I guess, maybe I should take this question out because in the previous problem, it tells you the p-value that it's greater than 0.10, which is kind of like, okay, well, if we're already given the p-value, doesn't that mean well, because here, look, if you have degrees of freedom and here's your t-scores, and it's getting smaller. As t gets smaller, the probability gets higher. So since it's smaller, it's going to be greater than 0.10. That's the idea. Could you technically calculate it on your calculator? Sure, of course. We could use the calculator for this. We would do TCDF, and then you would do negative 999, comma 2.704, and then the degrees of freedom is 7. Okay, so we would take this and multiply it by 2. Okay. And you would have something much greater than 0.1. Okay, so so let's see here. So the range here is greater than so 0.7. Let's see. So we have here 0.895. So for 7 degrees of freedom, 0.704 is less than 0.1895, but it's also less than this, okay? So then it's going to be twice that, approximately, more than twice that. So it's going to be greater than 0.10. So that's the same, that's the logic that they tell you. But I mean, I guess you could also consider You could also consider that you just read the same problem like a few seconds ago and they gave you that the p-value was greater than 0.10. I'm just saying. Okay, so then question 23. A manager of a home improvement chain is interested in switching the current brand of paint they sell to house brand paint. And then we take the difference. There are 8 paint colors. Is there sufficient evidence to show that the paint color increases for the house brand? So then we have to find the approximate range for the p-value, knowing that the test statistic is negative 0.241. Okay, then it says here, degrees of freedom would be 8. I mean, 8 minus 1, which is 7. So then you have to say, okay, well, this is a left tail test. So here, so test is left-tailed. Okay, and let's see here, what else do we know? We know that the test statistic is less than 2.41. So let's see here. So we have, what is between 2.41? What gives us to add 7 degrees of freedom? So degrees of freedom is 8 minus 1, which is 7. So looking at 7, where is 2.4 located? About here, right? This is, imagine it's positive because it's two-tailed. So it's just either one. So they have the boundaries. It's in between these two. So it's in between 0.025 and 0.01. Okay, so it's going to be between 0.025 and 0.01. So 0.01 and 0.025. Could we do it another way using the calculator? Yes, you could. However, it's a lot easier to use the table, I think, in this weird case, because it gives you the range. The table gives you the range where it falls. 0.025, like here, right? So, okay, so what if I wanted to use a table? Then we would do TCDF. Sorry, clear this second bar is TCDF. So it would be negative 9, comma, negative 2.41, and then degrees of freedom 7, and then time, and that's it. So if you were to calculate this using your calculator, you would get a p-value of 0.023. But what's 0.023 fall between? It falls in between 0.01 and 0.025. So that's why you would write that in here. So using TCDF, 7, we would get that equals 0.023, which is between 0.01 and 0.025. Okay, cool. That's this guy. Have a few more to go, I think, right? How many questions is this thing? Oh, I think the review is much longer than the actual exam. The exam's much shorter than this. Wait, do we still have time? We still have time, right? What time did we start? 8:30, 9:30. Okay, so question 24. We have a manufacturer of batteries want to test the longevity of one-time use and rechargeable batteries. So we have here employees working in research created 10 different pairs of battery, marking one of each type, put the batteries under a performance test, and measure the time it took for them to fail. Assume the populations are normally distributed. Okay, so this one is very similar to the other one, so I'm going to skip because you can do the same logic that we did before. So let's see here. Proportion of students in proportion to if school A has a lower proportion. So this is another question that's like the one before, where school A is, so it wants to know school A has a lower proportion of students diagnosed with then school B, right? So, but it wants to know the null hypothesis, right? So if this is the alternative, then the null would be that it's equal, because the null has to have an equality. So none of these do. So you don't even have to think of that to find A, right? Because it has the equal sign. Let's see what else. Okay, so it says here, check the conditions that are met for a hypothesis test to compare the population proportion prefer eating salad. So what do we need to have? So all the conditions are met, but why? So here are the conditions. Conditions. We have 1, random samples. Okay. 2, independent. So N1, P1, or P hat, right? N1, Q hat. N2, P hat, N2, Q. They all have to be greater than or equal to 5, okay? So we used a P, where P is equal to, it's pooled, so it's x1 plus x2 over n1 plus n2, okay? And then you use Q is 1 minus P. So then, yes, all the conditions are met. Okay, so that one's that. And then here we have sample of 1392 mosquitoes trapped in a region, 1,173 tested positive. In a sample of 1,457 mosquitoes trapped in a different region, 1,196 tested positive. So we need to compute the test statistic for a hypothesis test to determine the population proportion of mosquitoes for in the regions that tested positive. Okay, so we need to do this. We need to use this formula for this one. So you have P1 hat minus P2 hat, because it's a difference, and then minus the mean of the difference, 2, and then all over the standard error, P1 hat minus P2 hat. Okay, so we just need to go through the list here. So we have here, I wonder if there's a way to do this on your calculator. I'm try to think. Let's see here, hold on. Solution, you can do. Test to prop Z test. So, to test that positive to compare. So, let's compare that. Okay, so I'm thinking we could try to do, we can do this with the 2-prop Z test, but let me just make sure, because it doesn't say greater than or equal to, so I'm thinking it's probably different. So we get, yeah, okay, so I was right. So we could do it 2-prop Z test, or you can do the longer way where you do P1 hat is equal to x1 over n1, P2 is equal to x2 over n2, and then you have mu1, mu P1 hat minus P2 hat is going to be that they're equal to each other, or the difference in the population is 0. And then you have to find the error. And that use this formula. So the pooled n1 plus 1 over n2. Okay, and so you need to do that, and then you need to calculate this, which is x1 plus x2 over n1 plus n2. So that's going to give you some number, and then you need to find q, which is 1 minus p bar, and then you need to find this, and then the z, you need to plug it back into here. So you got to do all these calculations, or we could just do, second quit, or just do stat test 2 prop z test, because it's 2 proportions, okay? So all this, you know, and I didn't even show the work yet. This is just the formulas. Or you just use 2 prop z test. It's a lot easier. And you just plug in x1 is 1173. This is from the problem. N1 is 1392. So out of the 1,457 people, x2 is 1196. So you get all this from here. So from so this is n1, this is x1, this is n2, and this would be x2. Okay, so we're trying to compare them. So let's just put does not equal. So calculate, and there it is. So z is all you wanted, which is 1.55. So yeah, 1.55. Okay, that's it. Oh, and does not equal. P1 does not equal P2. Yep, so this is a lot easier to find the z, okay? And it gives you a bunch of other stuff too. It gives you all of this other stuff that you might want. So you have, you know, P1 hat, P2 hat together, and you can use that and plug that into here. Okay, all right. So let's see what else. 28, hypothesis below. Okay, so this one is already like the others. It's very similar where you have the alpha and then you have the p-value and you need to compare. So compare p-value to alpha. Okay, and then either fail to reject or reject. So this one is, the alternative hypothesis is that the population proportion is less than, spending is less than. Okay, so what is the two set? So basically it wants PZ less than negative 1.04. So if you did it this way, you would have to do 1.04 and this would be it. Sorry, let me just hold this outside a little bit. Let's see here. Yeah, so basically, so since you have negative 1.04, so here's negative 1.0, here's the 0.4, where do they meet? They meet here, and that's it, 0.149. So it's pretty straightforward. It's just where they meet. Cool. Let's see here. Let PB the proportion of physical therapy who've had a bone fracture. Draw a conclusion and interpret the results based on the p-value. So again, so this question is also like a p-value compared to alpha situation. So p-value is this, and then alpha is 0.1. Okay, so again, so p-value in this case is greater than alpha. I mean, less than alpha, sorry. Less than alpha. So what does that mean? We reject the null. Okay, so reject. So it's either one of these two. So it's not this and not this. But then if we reject the null, we support the alternative. Okay, support the alternative. So that would be B, because it says there is enough evidence to show that this. Okay, and it restated the alternative hypothesis. Okay, I don't know if I'll be able to get through it all, but I'm going to try. I mean, at least the ones, I'm not going to do any more repeats that are basically asking the same things. Okay.
Okay.
Huh? Question?
I said okay.
That's okay, right?
Yeah.
Yeah, because I mean, they're just asking the same question over and over again, but just like in a different situation, you know?
Hmm.
They're just like saying the same thing, but it's just over and over again. So yeah, so like this one is the same kind of thing where they give you p-value and then they give you alpha and then they say what's the conclusions. So remember you use p-value and the alpha to either reject, fail to reject. So like in this case, p-value is greater than alpha, so we're going to fail to reject, right? There is insignificant or insufficient evidence. So we fail to reject. So if we fail to reject HO, so we fail to reject the null, that means that we cannot support the alternative. So they're insufficient evidence. So a lot of these questions look like it's that. So that would be this one. So in this case, AD. Okay, good. So then it says an avid baker decides to bake chocolate chip cookies. Here's our profit. How much cookies does she need to break even? So that just means that the profit must be 0. To break even, that means profit equals 0. Okay, so that just means 0 is equal to -9 plus 1.5x, and we just solve for x. So then that'll just give me 6. So 6 cookies. Okay. This one's pretty easy. The linear ones are great. Okay, so then you have here, find the linear regression line. So we need to plug this in. We can just hit this into L1, L2, and then do it. So let's do that together because that is kind of, for practice. So let's see here. Okay, so clear stat, edit. We're gonna do L1 is going to be 3 our x and L2 will be our y. Okay, so that's L1. This is L1, this is L2. So then L2 will be 0.603, 6.03, 9.61. Oops. $16.31. Okay, and now that we have L1 and L2, we need to do stat calculate. Sorry. So stat calculate, okay, and then we go to linear regression. Okay, so L1, L2, okay, and then we need to just do calculate. So that gives you, remember the form. You also have to remember the form. So it's A plus B, they do AX plus B in this one. That's interesting. So A and B. So you just have to be careful because the book does like A plus BX, and then the calculator does AX plus B. So remember to watch out. So watch out. Calc uses y equal AX plus B, but book uses y equals A plus BX, right? So this A and this A are different, and this B and this B are different, okay? So just look at the calculator, okay? So what does that mean? So if you have y equals AX plus B, your A is 1.441. So you would do, so you would do 1.44x and then plus B, which is 3.13. Okay, so just make sure you watch out and use what the calculator gives you, okay? So if the calculator says A goes in front of the X, fine, we put that in front of the X and then the B goes right there, okay? All right, okay. So 3.4, I mean 34. Oh, so this is just like looking, right? It goes in a positive direction from left to right, it goes up, and it's linear. So it's just a positive linear pattern. So it's just there's no deviations. It's not too crazy. That one was a freebie right there. Okay, so okay, so this is the same thing, except that now we're just gonna plug in the calculator, okay? So we're gonna plug this into the calculator and we'll get our answer. So you just go stat, edit, edit. Let's see here, 2, 7. So basically we just plug into L1 and L2 and do the same thing, linear regression. And then you answer your question 2, 14, 17, 20, 23, 26, 28, 29, 31. And then you have 30, 45, 45, 42, 48, 47, 65, 78, 80, 87, 85, and then 80. Okay, so we do stat, tests. Wait, I'm doing, yeah. No, we're not doing a test, sorry. We're calculating. So stat, calculate. Okay, so we want this. So we do stat, calc, and then lin reg a plus bx. Okay, so calculate. So this one is a plus bx, and then this one gives us the y-intercept. Well, that's interesting. Didn't we do? Okay, I guess we picked the other one. It gives you the other way. So this one, it wants to know the intercept. Okay, so the intercept is going to be whatever number is by itself, so 13.8. So intercept is, in this case, was 13.81. Okay, so remember this is different. So this one is in the form a plus bx. I guess, let me see. I'm just curious like a cat. So here. Oh, I see. You have, so you can do ax plus b, or you can do a plus bx. So if you did ax plus b, you have here that the b is 13.8. See how the b is by itself? So just make sure you understand what's different. So there's a difference. So see, you can do this option or this option. I guess that's what, I don't know. That's what's on my calculator. I don't know if yours has that on as well. Okay, so 30 question. Oh, okay, so this one, remember to tell if something is significant or not. So we have R is 0.261 with N is equal to 23. So let's use the table. So degrees of freedom would be N minus 1. I mean, N minus 2. So we have here 23 data points. So 21 degrees of freedom. Okay, so then what is the critical value is 0.413. So if you have here negative 0.413, positive 0.413, and then what is R? R is right here, somewhere here, right? Let's see, sorry, 0.261. So it's, let's see, okay, there it is, sorry. So let's say here, R is here, 0.261, but that's in the no-no zone, okay? That's like in the not significant area. So you would say not significant because it's between the positive and negative critical values. So that was pretty straightforward. Okay. And then 37. Okay, so what would be the predicted number of minutes spent outside for someone who spent 68 minutes exercising? Okay, so you just have to plug it in, basically. So they're giving you the formula. They're giving you y hat is equal to 0.16x plus 45.5, right? And x is time spent exercising and time spent outside. So you can predict the time spent outside because 68 minutes, it's barely within the range. Like it's like 2 minutes away. So you can you can still put it in, even though the textbook tells you it's not exactly, but in this case, it's okay because it's very close. Plus 4.55, 45.5. So your y hat is 56.38. So predicted minutes is 56.38. You just plug in. So plug into X. All right. And then we have, which of the following scatter plots have one or two more outliers? So we have to look at the different ones and see which one looks like they have at least one or more outliers. Okay, so really the only one that looks like it would be D, right? Because they're all pretty close together. Except for D here, you have this guy. So it would be D.
Yeah.
That's pretty much it. Yeah, it's pretty straightforward. Okay, then let's see here. Which of the following are feasible equations for a least squares regression line, number of dollars spent left? If its first 10 years, it was entirely funded by a single donation. So you have dollars left if it was entirely funded. Okay, so there was an initial deposit, and then it's going down because it's saying how much is left, right? And it's going to go up to 10. So basically, this one is kind of more like, do you understand like what lines mean? So like this one says, okay, so it was funded by a single donation, and then you know that it has to be left, dollars left, so it's minus. So that means that money donated, and then you take away some like per year. So subtract money per year that was spent. Okay, and then X has to be about 10, right? For the first 10 years, so it goes from 1 to 10. So so then we say, okay, well, if it's plus, it has to be minus, because once you're given a donation, if you use it, it's gone. You don't add to it, right? So that rules out not this. Okay, now the donation would be the initial part, so that can't be it. Then you wouldn't donate negative, so that's that. So now you're left between 69,000 and 269,000. Well, let's use our logic a little bit. This is 8,300x, okay, per year. If I multiply this by 10, I'm going to get 83,000, which will leave me with a negative number. So no, this will leave me with negative number if x equals 10. So no. So it has to be this one, okay? So it has to have a value equal to the initial, and it has to decrease every year. Okay, so and no additional, right? Okay. And then we have here 40. True or false, the higher the parachute is open, the longer, why is it? Okay, the longer it takes to descend. Changing the height will, okay, so yeah, that's true. It seems kind of a weird question there, but okay. Oh, so SSE and T and SSR. So this was from, I might take this out actually, but just if you, let's see, if you do see it, this is the relationship. Okay, so you just basically have to find the SSR if you're given SSE and SST. So I might remove this because I don't think I talked about that. Okay, so, but just in case, that's what the equation is. So you would put 97 is equal to...
It's 48, isn't it?
Huh?
It's 48, that answer?
Yes, 48. This one's an easy question, but I don't know if I went over this.
I don't think so, but then like I didn't. I was like, oh, okay.
It's really easy, yeah. It's really easy. It's just if you know this. But I think I might have taken this out. I don't know. We'll see. Because it's too much, too many questions. Okay, so I think we're almost done. So here, last page. Last page. A farm recorded the number of years of experience on each farmhand, bushels per apple. Oh, see, so again, so this is the coefficient of determination. There's a formula to calculate it, but I showed it to you guys on the calculator. So you could do calculator, and then you do the regression line, and it gives you R squared. So it wants R squared. So we could just enter this L1, L2, and then do linear regression. Or you could use, there's a relationship between R squared and the sum of squares and the sum of squares of error, and it's this. Or we could just plug it in. So we would do stat, edit, and then you do your two lists. There. Okay, so let's see here. Sorry. So let's enter this really quickly. So 4, 5, 7, 9, and then 10. And then we have 39, 51, 67, 67, and then 77. Okay, so second put, and then you do stat, calculate. Okay. So when you do your linear regression, I just did the first one I saw, your R, it gives you R squared. That's what's asking you. So coefficient of determination is R squared. So that's your answer, 0.9021. So yeah, so see, it's right there. Or you could have just, or you could also plug it into this, okay? But so it's L1, L2, then stat, calculate, and then linear reg, okay? All right, and then this one here, it wants to find R, okay? So to calculate the correlation coefficient is R. So you do the same thing where you put L1, L2. So L2, L1, L2, so you need to put GPA and attendance. So let's go ahead and do that. So it's the same thing, but except it's sideways. So let's go ahead and enter that into L1, L2. So we just clear our last work. So okay, and then L2. So 0.97. Okay, and then once you enter it in, you just stat, calculate, lin reg. So stat, calculate, linear regression. So you do, so this is what I did. This is L1, this is L2. Then you do enter into L1, comma L2, then stat, calculate, and then the linear reg. Lin reg, and then you get R. So R is 0.41, so R is 0.41. Okay. Okay, so then this last question is so then basically, so another thing, you have to find the equation of the regression line. So same thing, L1, L2, you know, and then the same thing, stat, calculate L1, L2, and then you do stat, calculate, and then linreg. But let's just do it for funsies. It's our last one, right? And look, it's in AX plus B, so maybe we can just choose that one. Okay, so remember it says find the slope and the intercept to 2 decimal places. So this one is the slope, so slope, and then this is intercept, right? How do I know that that's the slope and not the intercept, right? How do I know the difference? Because the slope is always in front of the x, right? Coefficient of x. Doesn't matter what letter it is, it just matters that it's in front of the x, the coefficient of the x. Okay, so let's plug it in. You know, you plug it in, you're gonna get, let's see here. So I did not plug it in yet, so let me just quickly do that. Edit, so stat, edit, and then you have 3, 21. Wait, 30,000, 1, 2, 3, 4. 300,000, 10,000. And 0. Well, I have it here anyway. So let's see here. So you do L1, that's your X. L2 is your Y, right? And then you do so enter, right? L2, and then you just hit why do you want, wait, you don't want to graph this, do you? You just want to find the slope and the y-intercept. So you just do L1, L2, and then stat, calculate, linreg, and here's your values. So if you have AX plus B, if you do AX plus B, then A is 0.03, and then B will be 4323.82. Okay, and then yes, if you did A plus BX, then your A would be 4323.82, and then your B would be 0.03. Okay. So I just wanted to give you both options in case you selected one over the other. All right, so that's all I have. Yay, we did it. Any questions on exam 3?
When is it?
I'm going to open it today. Okay. And then I'll have it due, what, Thursday? Is that good?
Okay. Yeah.
And I'll, yeah, I think that's good.
I have another question, but it's not related to this. Is there any school officials at Cerritos right now?
Oh, anybody at Cerritos on campus?
Yeah.
I don't think so. I don't know. I thought they closed campus pretty much. Why, you needed something from school?
Yeah, because I have this paper that I need someone from school to sign, like for my GPA. Because I missed the deadline for March 2nd, and like I really need someone like to sign off on it. But there's like no one I could find.
Is there any way that you can email somebody?
I think so, yeah, but I'm not that sure who to email.
Like who would you go to sign it?
Well, it just says
It's just what?
like on the paper says signature of school official and then like the title of the school official. So I don't think it really matters who, as long as it's like they could prove that they're from the school.
Oh, that's, but, You mean like someone in admin?
Yeah.
Huh. Okay, so, I don't know who.
Just email admissions.
Yeah.
Yeah, because I emailed them because I needed to do something too, and they respond to you.
Okay, thank you so much.
Mm-hmm.
Yeah. Okay, cool. So, just check your Canvas. Let's see here. Did I put in for the exam? Okay, so I already put quiz 10 and 12, right? I don't owe you any other quizzes.
Yeah.
Yay! So let's see here. This would be midterm 3 and 9 through 12. And then I guess we'll make it due Thursday. Okay, done. Thursday night. Oh, geez. Let's see here. Oops. 160. Okay, and then. All right. So if you guys can just check your Canvas and tell me if it's on.
Thank you.
And then if you see it, you're free to go. Okay, cool. Yeah, if you guys, yeah, so.